Hi everybody, welcome to our first video here on organic chemistry. So our goal here is to really supplement the handouts that you're getting in class on organic chemistry with some very short videos. We want to try to keep these videos as short as possible because you're going to have plenty of added detail in the handouts. So this first video is going to be on alkanes, as you can see up here. Alkanes, quite simply, are organic molecules in which all the carbons are bonded to one another with single bonds. There are no double bonds, there are no triple bonds in these molecules. The first thing we have to appreciate about alkanes is really how to draw them. So alkanes essentially look like these kind of guys here, and anywhere you see a dash that represents a bond to a hydrogen. So for example, right here, there's a hydrogen, here there's a hydrogen, and then there are hydrogens here, 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 here. I'm just getting too lazy, I don't want to draw it all out. Now, in terms of naming, this alkane has, as you can see, 1, 2, 3 carbons in it. So if you look at the root name chart on the handout, you're going to see that this compound is going to be called propane. P-R-O-P, prop, for having 3 carbons, and ane, A-N-E, because it's an alkane, and all alkanes have the A-N-E ending. But this isn't how we're going to draw alkanes. We're not going to draw out all the carbons with all the bonds with all the hydrogens, because as we get to larger, more complex molecules, it's just going to become a nuisance. So the way we're going to represent this molecule, this is going to be equivalent to drawing a structure that looks like that. Okay, I kind of call this sort of the ends and elbows notation, I guess, where the elbow of each line, right there, there's a carbon, and at the end of each line, there are carbons as well. And so I just draw sort of these crooked lines to represent organic molecules. So for example, take a look at that guy. How many carbons are in that molecule? 1, 2, 3, 4, 5. So this is the alkane pentane. I can also draw structures, I can also draw structures that have some branches on them. I could put a carbon there, I could put a carbon there. So take a look at this guy and tell me how many carbons and hydrogens are there. There are 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this is going to have the formula C8. And now let's count the hydrogens, okay? Now we need to have enough hydrogens that will complete the octet. So there are 3 hydrogens there, 2 there, and only 1 there. So if we count this up, we've got 3, 5, 6, 9, 10, 13, 15, and 3 more for 18. So this is C8H18. Now for alkanes, this is going to be generally true. Alkanes are going to have the general formula of CnH2n plus 2. So going back to my example here, C8, so N is 8, and then 2 times 8 is 16, plus 2 more is 18. So all alkanes are going to have this general structure, CnH2n plus 2, or I should say general formula, okay? So you're going to need to be familiar with how to name alkanes that have 1 to 10 carbons in them. So all the way from methane up to decane, and the various branching structures thereof. So let's talk a little bit about branching structures. So I'm just going to go ahead and get rid of some of the stuff we've drawn here, just to clear up a little bit of space. Okay, so let's talk about branched alkanes. So what I want to be able to do is I want to be able to name, don't like that structure, whoops, sorry. Just clear this up a little bit. Okay, so what I want to be able to do is name structures that look something like, let's say, that. All right. Now, The rules for naming alkanes is we first want to find the longest carbon chain. Now the longest carbon chain is 1, 2, 3, 4, 5, 6, 7 if I count it that way, 1, 2, 3, 4, 5, 6, 7 if I count it that way, 1, 2, 3, 4, 5, 6, 7 if I count it that way. So no matter how I count this, I see 7 carbons as my longest chain. So this is going to be based then on being a heptane. Now, in addition to it being a heptane, I also have a branch. Right here, I have this branch. So I have to account for the location and the size of that branch. So to name this guy, I'm going to name or count this as carbon 1, 2, 3, 4, 5, 6, 7. And then the branch is 1, 2 carbons long. So the way to name this molecule is, so it's going to be heptane. The main chain is heptane, so I'll write that in the same color, red. So the main chain is a heptane. And then on the third carbon of the main chain, I have a 2 carbon long chain right there. So then the full name of this guy is going to be 3 hyphen, and now if it's 2 carbons long, it's called an ethyl branch. So the full name is 3-ethyl heptane, okay? 3-ethyl heptane. Now, so again, 1, 2, 3 ethyl, 1, 2, 3, 4, 5, 6, 7 heptane, 3-ethyl heptane. And the idea here is I don't number the molecule going in this direction because that would give the branching chain a higher number. I want a number so that I get the longest chain, and then any branches like this ethyl branch get the lowest number possible. Okay, so that's really the logic of what you're seeing on the handouts. So we'll stop this video here. You can look at the handout to get some more examples. The next video, I'll take a look at maybe some more elaborate structures, including some cyclic alkanes.